Okay, so the next segment is I gotta beat this with a rubber hammer. Right here I have a toroidal transformer, and I have a linear motor actuator. I have the battery inside of here. Here's the metal bond of the battery. I have the coil, Hall effect coil going this way, and the toroidal transformer going this way. And I'm going to wrap it up with a thin bicycle steel brake cable. And I'm just going to spun around all of it up in a linear with a bicycle cable. The foam here is to replicate my foot metric range. And that's the second part. It's just to wrap it up with the iron steel cable. And then resin it. And the essential, whereas the foam exhibiting, I'm going to extract the foam and use copper and iron and aluminum sheets. Starting with the first foundation is aluminum, the second foundation is iron, the third foundation is copper. So, and to repeat that segment in stacks like a stack commuter. And this will be in the center of the stack commuter. And then what I'm going to do is, along the sides, I'm going to try to leave it at a little bit of distance and range and try to curve it out so I can sink it in like cups on top of one another, intercept it. And what I want to do is coat it with sodium acetate and crystallize it in sodium acetate. And then I'm going to add silicon carbide at the top, and then I'm going to enclose it in a plastic, polymer plastic. The open clearance right here, I'm going to crush and burn some ceramic magnets and crush it down to powder and place it within these ear gaps of the coil. And then I'm going to resin it. I might add quartz crystals along with it, and I might add silicon carbide along with it. Now, once I apply the steel wire around here and I'll resin it and coat it, and then the bottom I'm going to use rubber, translucent rubber glue. So I can have a nice rubber bottom. If I want to reface it to overlay it, so the top part, after I do the iron wire, I am going to add the metal sheets on top of the wire, even though I'm going to have it in an ear gap. And I'm still going to use aluminum bottom and a copper top to enclose it. So it's just a process, and it takes time, so should be no questions. It's just actually a process. That's about it. And to lift, this is more coil than your conventional motors. So what does a motor usually have? You know, either permanent magnets, a stack of sheets of metal, and copper. I don't need to deteriorate or take off the coating of copper, just like magnetic wire. It has a coating on it, protective coating. The same thing. So I don't need to deteriorate or take off the jelly, PVC jelly, off the enclosures of this coil. It is 16 gauge and 14 gauge together, and it has about 20 phase wire segments. And it's like, this is wrapped more than a couple of Teslas. One Tesla is like 12 feet of wire. So this in series is about more than about 240 something feet, about 247 feet. So we say we have about a half of 41 Teslas. 41 Teslas is 500 pounds. So under that, we'll say it's about 21 Teslas.